This is a demo video for a tourism itinerary recommendation system incorporating natural language interaction and score-based algorithms. Tour planning is a time-consuming process. Users need to collect information such as POI popularity, cost, opening hours, and transportation details. Furthermore, users need to create an efficient and satisfactory route by considering various constraints such as cost, duration, opening hours, must visit POIs. Existing recommendation systems based on score-based algorithms such as Trip Builder, Push-to provide efficient and high satisfaction recommendations. However, they have limitations in handling complex constraints made by natural language queries. On the other hand, chat-based recommender systems like ChatGPT can process diverse user conditions but lacks guarantees for efficiency and satisfaction. Additionally, they may give hallucinations, requiring verifications and potential replanning. Our system combines the strengths of both approaches, offering recommendations that are efficient, high satisfying, and can handle diverse natural language user queries. This is the overall system architecture. Our system consists of a chat module, a recommendation module, and an explanation module. The input for our system includes user chat and constraints such as cost, time, start-end point, start-end time, total number of viewpoints, and must visit POIs. The output of our system consists of a timeline, explanation of the timeline, and chat. The chat module first classifies user queries into 5 predefined intents: parameter update, user preference, area restriction, time specification, and general chat. The first intent has an input into the corresponding modules accordingly. We use a score-based algorithm that evaluates each route based on the sum of the popularity score, moving probability score, and total travel distance score. If a preference query such as "I want to go to historical place" is given, the query inclusion score is added to the total score. We handle other constraints such as spot time constraints and must visit POIs heuristically. Routes that satisfy the constraints and have high scores are selected, and beam search is used for efficient exploration. Now, let's move to the demo. We created a demo using Hyogo Prefecture in Japan. This map highlights some of the top 20 tourist spots based on review counts from Jaran.net. Many well-known attractions such as Nankinmuchi, Kitano Ijinkan, and American Park, Ikuto Shrine are concentrated in Kobe City. On the other hand, places like Arima Onsen, Kinosuke Onsen, the famous night view spots Mount Rokko, and the UNESCO World Heritage Site Himeji Castle are located further from Kobe City. This is the interface for the demo. The left side shows the map, and the right side shows the control parameters. We can choose Japanese or English for the language. We can select hotels or tourist spots for departure and arrival. Let's select a hotel first. Now let's recommend the routes with the default settings. The default number of viewpoints is 6. After a moment, it generates timeline. A timeline contains the cost and time information. The recommended routes efficiently pass through Kobe's famous spots like Arima Onsen, Kitano Ijinkan Suite, American Park, and Nankincho. Since the route ends quickly, let's increase the number of viewpoints. Now the generated routes also end within the time limit, and the result seems better. Now let's find more cost-efficient routes within a budget of 1,000 yen. It has now generated a more cost-efficient route. We can also control the starting and ending times. Let's delay the departure time and set an earlier arrival time. It successfully generates routes accordingly. Now let's set a must-visit POI such as the famous Himeji Castle. The generated routes now include Himeji Castle. We can adjust the weight of popularity and distance using the weight bar, making the routes more efficient or more popularity focused. Let's try it with Himeji Hotel. First recommendation is with the default settings. They suggest popular places in Kobe. Now let's increase the distance weight and lower the popularity weight. Now they recommend the places near Himeji. Now let's reset parameters and move to the chat feature. Our system can handle diverse natural language user query. First, we can specify area restrictions such as I want to go to Ajishima. Ajishima is famous for its gourmet, beautiful scenery and nature. After waiting, the route successfully passed through Ajishima. Secondly, our system can also handle user preference queries such as I want to go to places children can enjoy. The routes now include places like Ampami Museum, a zoo, and an aquarium, which are popular among children. Thirdly, our system can also specify time constraints such as we want to go to Mountain Rocco at 6 p.m. to see the night view. The system generates routes that arrive at Mountain Rocco at the specified time in all routes. We can include multiple queries simultaneously. I added an additional query of I want to visit historical heritage sites. The system now recommends places such as Himeji Castle and Akashi Castle. It also ensures arrival at Mountain Rocco at 6 p.m. We can also use chat to collect information, for example by asking about events. It provides information about winter events in Kobe. Explanations about the generated routes are provided below the chat space, showing POI details and route descriptions. That's all for the demo. Our system can provide efficient and satisfactory routes with diverse user input. In conclusion, we developed a demo system for efficient and satisfactory itinerary planning with diverse NLP input, integrating a chat module to process user queries. For future work, we aim to enhance agentic capabilities to handle any query, improve route optimization, multi-day planning, and incorporate real-time transport, restaurant data, and various budget options for tourism expenses. Also, we want to enhance response time for our system. Thank you for listening.